Hello YouTube, welcome to my channel. I'm going to show you today how to create a IR transmitter. So what I'm using as my power source, pretty simple, using 5 volts from a AC to DC converter. This is a Samsung converter that I use for my phone. You could do this with any AC to DC converter. USB cord, strip it out, tie some stronger wires to it, and make sure that they're not going to touch each other because you don't want to short it out. You'll blow a fuse in your house. Because this thing delivers 2 amps. Normal fuse in your house is about 2 amps, and you're running a lot of other stuff, electricity, whatnot, throughout the house, you know. And yeah, so that's my power source. Now let's get down to the real business of it. Here it is. So the main this is a perforated circuit board, if you don't already know that. It's good. Before I had it on a little proto board. So here it is. So I have a push button start. It's just going to be an on-off remote control. In the center, there's a 555 timer. And once you click that, it will turn this big, bulky green LED on to show you that it's on. There's a little NPN transistor in there, BJT. And I recommend you get a transistor kit. I have the Elanco transistor kit. I love it. I bought it at Micro Center. Works great. And so, and then it has a IR LED here, your BJT, which is your NPN transistor. And you got to remember that for RC circuits, anything that, so an RC circuit is also known as like a RC is also your time constant. So you want that to be as low as possible if you want a faster frequency. Because remember, frequency is 1/seconds. So you want a very small time constant. Faster frequency, you want, so you can just play around or you can calculate it. Calculating usually gets you in the ballpark, and then you just change values in order to get it to the actual value that you're looking for. So I designed around a 10 kilohertz signal. So to test this bad boy, let's hook it up. So as you can see here, I soldered on these junctions. And so let's plug this in. So as you can see, it turns on. You'll probably be able to see the IR LED turn on so you can see how it turns blue. I'll block the green behind it. See it turning blue? That's the infrared light. Our phones can see it, our cameras can see it, but not us. I recommend a helping hand. So let me turn you. I wish I could turn you around, but I can't. Okay, so right now I haven't filtered out on my receiving end the ambient noise. And ambient noise works at a frequency of 120 hertz. So we're gonna want a high pass filter in order to get rid of that. Because as you know, high pass filters, they let through the high frequencies and they filter out the low frequencies. So we're going to use a high pass filter. We're going to use a band pass filter to get even rid of more noise. All the noise around your apartment that you wouldn't expect, we have to filter that out just around the 10 kilohertz. Then we'll use a low pass filter and a band pass filter in order to get it even closer to what we want. So here we go. turn it on. As you can see on the oscilloscope, 10.1 kilohertz. So I'll do another section on the receiving end once I have that all hooked up. And I'm putting it on the perforated proto board because I'm going to use this to turn on my night light. So that way I have a remote control for my light. So that will be using a relay, and like I said, all those components earlier, also a flip-flop to turn it on and off. And yeah, you essentially need an oscilloscope and a power supply, wire cutters, multimeter, the whole shebang, soldering iron. That's if you want to do it on perforated circuit board. And I think it's great. I'm going to do more and more of these videos. I don't think many people are going to watch them, but as long as like 20 people watch them, I see a reason to do it. Alright. Talk to you again soon. Bye.